episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor.
Welcome, everybody, to another episode of our show with another truly fascinating individual who is helping to create a better tomorrow for all of us. Today, we have the pleasure of being joined by Nadeem Nathoo, who is the co-founder of a group called the Knowledge Society, which is defined as a human accelerator that focuses on exponential technologies such as artificial intelligence, virtual and augmented reality, nanotech, Internet of Things, ultimately with a core mission to develop young people, somewhere in the range of 13 to 17, to help pioneer these new industries using these emerging technologies and sciences. Knowledge Society alumni have spoken at some of the world's largest conferences. They've worked at some of the largest companies in the world, like IBM, Microsoft. They've raised money for startup ventures from the top investors in the world, and they are out there building projects in areas as diverse as brain-machine interfaces, quantum computing, genetic engineering, just to name a few. Prior to the Knowledge Society, Nadeem was a management consultant at McKinsey Company. There he aided a variety of Fortune 500 companies in a disparate range of industries, including banking, mining, aerospace, telecommunications. He has led turnarounds, growth strategies, M&A, upwards of $2 billion. And he has done work in many far-flung regions of the world, from Tajikistan, Kyrgyzstan, Bangladesh, East Africa, Honduras. In his spare time, he does some angel investing. Nadeem, thank you for taking the time out of your schedule to come talk to us for a little while.
This is awesome. Let's see where it goes.
Absolutely, absolutely. I love the quote on your website. It says, "We wanted to build what we wish we had growing up." And as an outsider looking at what you're building, I wish I had this too when I was growing up, and I wish my kids who are now getting up there also had this. Take a little bit of time, if you would, just to talk about yourself, your brother, who I understand is the other co-founder of the Knowledge Society, and how you got this idea to build what you've built here.
Well, it was a classic immigrant story, right? My dad grew up in Tanzania. My mom grew up in Uganda. My mom got kicked out during the Idi Amin time, so she came to Canada, and likewise with my dad went in Tanzania when they nationalized all the properties. So my dad had a grade 9 education, couldn't really help me with math. I mean, he was super hardworking and he was very street smart, I guess, and he was a hustler. But in terms of academics, when I was growing, I was fortunate to grow up in Calgary, in just a place where there's not a lot of violence and crime. Like life was good growing up. And I don't know where this came from, but I was a curious kid. I was an ambitious kid, and I didn't really have a lot of environments to foster my curiosity or an ambition. I was a good student. I had good grades. And impact, I think fairly early on, and I think this probably came from my parents and even the culture that I grew up in, impact was the North Star, right? How can I maximize the impact that I can have on the world? And I just felt like I was going through this system, like I was a little bit of a sheep, and I wasn't really able to articulate it at the time because I trusted that this was the path that people need to go through in order to maximize their potential. And after I went to university, and while I was still in university, I actually realized that this system and this path was built to mitigate risk and not optimize for success. And that isn't necessarily a bad thing. Like if you're not curious or ambitious, maybe the answer is to mitigate risk for some of these people. But if you are, and you have something else pulling you, well, then how can you be put in environments where you can uncap your potential? So that was one piece. And then the second piece was, it wasn't really mapping towards my North Star, right? Of how can I maximize the impact that I could have in the world? And you mentioned when I was working at McKinsey, I had some really awesome experiences there, but I was just making the rich guy richer, right? And it wasn't really about impact. And what I found myself doing in my spare time was working in or going to these developing countries. So I was in Bangladesh working with Muhammad Yunus on figuring out how to get people out of ultra poverty using microfinance, or went to Tajikistan to build early childhood development centers for people in that region. And these weren't things that you applied for, right? It was an opportunity. It was something that I was exposed to. And I was like, hey, I really think I can play a part in trying to solve this problem. So I created these opportunities to add value there. And when I reflected, I was like, that's what I would choose to do like I would take time off McKinsey to do these things. So I'm like, okay, I started to get to understand a little bit more about myself, understand a little bit more about the world. And even though I had a business background, I was a technologist at heart. And I was always, again, very curious. And I got into the blockchain space fairly early on when it was not cool. Trading volume was super low, right? And you just had to be nerdy and really get excited about the technology and the prospect of this. But I remember while we were down in these developing countries, we thought to ourselves, we're kind of having this one-to-one impact, right? But again, as technologists, we should be able to have a one-to-many impact. That is the beauty of technology. And I was thinking about it, like this is the first time in human history where people have the ability to impact billions at scale. So 500 years ago, 1,000 years ago, if you wanted to impact billions, you had to be like a Galileo or Conqueror or Einstein or something like that, right? Whereas today, you almost had to die for your impact to propagate throughout history and be realized, right? Whereas today, if you have a device, you have the potential to write a couple lines of code and give financial literacy to everybody or build mobile wallets for the unbanked. The infrastructure is there. And so we realized that's going to be a really important part. And we did this thought exercise where, 30 years ago, there was this new wave of technologies, right? There was the internet, there was satellites, planes were becoming much more common, all these things, mobile technologies, right? And what I like to think about was what are the problems or opportunities that wouldn't have existed without those technologies? So for example, without the internet, it would be impossible to have e-commerce, right? There would be no E in the e-commerce. Yep. Without mobile, it would be virtually impossible to have the shared economy. Without satellites, it'd be virtually impossible to provide internet to developing countries. They kind of leapfrogged over Wi-Fi, right? And went straight to data. And so what I like to think about in the last 5 to 7 years, we had this new wave of technologies, AI, quantum, nanotech, gene editing, stem cells, and asking the same question. What are some of the problems that are virtually impossible to solve or the opportunities that wouldn't have been there without these? And if we think about cancer is a good example. In the last, this is actually the first year where mortality rates per capita in North America and the most developed places in the world have gone down. They went down by 2%. But from 2017 to 2019, mortality rates per capita from cancer were going up. But we spent $500 billion in the last 30 years. So what is the metric of progress here? That should be the metric of progress. And my hypothesis is maybe cancer is impossible to solve without the intersection of CRISPR and nanotechnology, as an example, right? But this is where the opportunities tend to come up. And so, and I promise I'll shut up soon, but when we went down to Silicon Valley, we thought we were going to find a bunch of smart people working on hard problems, right? And that was and find our tribe. And we were still young at the time. And while there was definitely pockets of that, and just a quick side note here, my brother started an AI company, got acquired by Box, and he was leading their AI and machine learning team. So that's how he kind of got down to the Valley. No technical background. When he first started the company, he didn't even know the difference between a designer and developer. He hired a designer to develop his backend. 4 years later, he's the head of AI at a multi-billion-dollar company, which is pretty interesting. And so that goes to show that you can take a little bit more of an unconventional path. But anyway, we went down to the Valley, thought we were going to find these smart people working on hard problems. And there's pockets of that, but there was a lot of smart people working on what we thought were dumb problems. Yeah. Like Uber for bartenders and Yelp for dog food. And by the way, those are two very real examples. And if I showed you the types of people who are working on those, you'd be like, dude, you could literally be curing cancer right now. Right. Like, why are you doing this? And philosophically, we felt a massive responsibility because the thing that we realized is, there are amazing allocators of capital in the world, right? There's the Bill Gates, Jeff Bezos, Chamaths, Elons, like whatever, who just know where to allocate capital. And it was very clear to me that as a civilization, we were doing a terrible job of allocating human capital. Yeah. Where should people be working or spending their time to maximize the amount of positive impact that you can have? And it's interesting because if you did, again, this thought exercise, imagine there was a king or queen of the world, right? And their main KPI was to maximize the quality of life of all their royal subjects. Does that seem like a reasonable goal? And hopefully it's reasonable, right? So say they're maximizing quality of life. And say every week they got a list of all the things that were adversely impacting quality of life, right? So you have mental health, climate change, poverty, all these things.
Yep.
And imagine this person looking at the list and being like, actually, I'm just going to let my royal subjects figure out the answers to all these problems without any help and without even being able to see this list. That's weird, right? That's the world we live in.
Yeah.
And that's messed up. Like what this person would do is say, oh, this is a problem. Let's get these people here who are best suited to solve this problem and solve this problem. Oh, we don't have enough smart people or capable here to solve this problem. Let's train them to do this. And so that's what we realized is the thesis was there's not enough smart people in the world to solve hard problems. Our impact was North Star. We realized that we were in a system that was built to mitigate risk and optimize success and versus optimize success. And so the naive idea, the simple idea was, let's develop an institution that specifically trains people, young people, to solve important problems. And the reason why we focus on young people is because, you know, imagine you wanted to be an Olympic level swimmer. You don't start at like 19 or 20, you start at like 10, if not younger.
Yeah.
But what's interesting is like, how many 14, say the Olympics didn't exist, how many 14-year-olds do you think would wake up one day and say, you know what, I actually want to dedicate the rest of my life to being super fast in the water without the Olympics? Like, I really feel like there would be far less people who do that. But what's interesting is we do have 14 and 15-year-olds waking up today being like, you know what, I do want to play a major role in putting a dent into climate change or solving some of these really important problems. But then they're 22, 23 sitting at a desk as an accountant being like, what the heck happened? Yeah. And there's nothing wrong with being an accountant. But if you didn't want to be an accountant, if you had the potential to do more and all these other things, then yeah, I mean, you were failed by a system that you trusted. And so the naive thing was, how do we build an institution to specifically train people to solve important problems? That's how we started. And then TCAS sort of evolved from there.
And working off of that, you know, once I'm pulling from your website here, but as you say, many of these problems are waiting to be solved by the next generation of people who care about the future of humanity. At the Knowledge Society, we believe that society can't sit around and hope someone will solve these problems. We need to be intentional about training these people to learn how to solve big problems at a young age. Very profound. And as you know, we're discussing offline, I've met some of your graduates that have come through the program, amazing young minds. Talk a little bit about where you find these minds. Is this, are you finding all the diamonds in the rough, or are there millions of diamonds out there? And if we can just give them the right push at an early enough age, get them interested in the right stuff, versus the new app or what's going on TikTok or whatever, we're going to solve all the world's problems in the next year. And we don't have that much more to worry about. Talk a little bit about how you find these people.
So there is a common misconception that we are a filtering institution, right? We're taking all these kids who are already working on these amazing things. Nina, specifically the young woman that you were talking about, she
Yep.
joined at 12 years old. She didn't know anything about anything. You're not supposed to know anything about anything at 12 years old. Her first presentation she did at TCAS, she couldn't finish. She walked off crying, and I know she would remember this. And she recently, last year, spoke in front of a stage of like 5,000 people getting a standing ovation, right? So the level of development, it really is about how can we find people who are high potential and maximize the probability that they reach that potential. So again, students who come to TCAS, they don't really have this exposure. They don't really know how to code, but again, they're curious, ambitious, and they're willing to put in the work. And sometimes they don't even have all three. Sometimes they just have two of the three, and we can train the other one. So I'll give you an example. Imagine there was a student who was sitting at the back of the class, always daydreaming, always curious, but never really put in the work because no one told them why, right? Well, you can train that work ethic. Or say someone's working really hard and they're doing all the courses and they're trying to do all the things, but no one told them they can think big, right? So I do think that you can train these other two pieces. But going back to what the philosophy of TCAS is, it really is mining the resource of human potential. I actually think this is the most powerful and important resource in the world. It's not gold, it's not oil, it's people, it's human potential. And if you don't subscribe to the fact that people just in North America who are born into great families and good circumstance biologically only have the potential to do really amazing things, then your view should align with mine. Like just by virtue of where you are born, you are not able to unlock your potential. There's a lot of people who are struggling to even eat, right? So they're focused on survival, let alone thrival, but they might be super high potential.
Yep.
Physiologically, biologically, just in terms of how their brain works, their personality types and all that stuff. And so, imagine you could get those people out of those environments into new environments where they didn't have to worry about any of those things, where they didn't need to worry about social pressure. I mean, parental pressure and social pressure is another huge example, right? You could have a student who has the potential to do some really incredible things, but and this is especially true in Indian and Asian cultures, where it's like, no, don't be the entrepreneur, be the doctor, be the lawyer, be the engineer, because that's what we spent so much of our time and sacrifice to get you that education. And so now a lot of young people who want to go in a different direction, say you're like really interested in sciences and you want to just explore that, no way you can do that, right, in that culture without kind of going through some very having some very difficult conversations. But it's like, even those difficult conversations are a barrier for a lot of people to unlock that potential. And so TCAS is meant to be an environment where, so let's talk about how do you unlock that potential, right? Mm-hmm. So we talked about teasing that ambition. We talked about getting people exposure to certain things, getting people to feel less insecure. So how can we remove the roadblocks that they put on themselves to be able to do things? And really, at the end of the day, it's how do you remove roadblocks that the world puts on them, and how do you remove roadblocks that they put on themselves, right? And if you can do that, then you should be able to see, and you put them in an environment where, again, the goal is to maximize success versus mitigate risk, you'll see a lot of young people doing some really incredible things.
We talked a little bit how, I met Nina last year. She's very interested in aging. We'll get to her company in a little bit that she spun off at the ripe old age of 13. I had an opportunity a couple of weeks ago to meet Orna, who is interested in artificial intelligence, biotech, oncology, dealing with climate change. Talk a little bit about how the core program works, how you decide, hey, Nina, you're going to work on aging today, Orna, focus on climate change. Talk about the challenges. And then if you would, you have an amazing range now of corporate partners that these youngsters go to, Walmart's, Nestle, Microsoft, and so forth. Talk about interacting with some of these large players and how they look at this generation, this new generation of amazing minds. Take us a little through that.
Cool. So let me talk about the TCAS process first,
Please.
Right? How do we get someone to go from A to B, right? Yep. Nina, where she is right now, starting this longevity company, working with some of the top researchers in the world. Well, the first piece is exposure. We call it the T model, which is pretty common, right? How can you get the breadth of exposure and then depth of expertise? And so when we think about the program and the resources that we have and how it's designed, it really is designed from a sessions perspective and a resource perspective around this exposure. And there is this notion out there, and I do think it's important, this idea of passion. Mm-hmm. But we use this word and it's very nuanced. It's how can we find our passion? I really don't like using that word because it almost feels like you're going to be walking around, you see your passion on the floor and you pick it up and you put it in your pocket and you're like, oh, I found my passion, right? Mm-hmm. I actually think passion is developed. Spending a lot of time, it's almost like developing your best friend. Sure. So say you meet someone and you were like, you might not even like them at first, right? And you spend a lot of time with them and you go through some laughs, cries, maybe climb a mountain together, and 2 years later you'll wake up and you're like, I think you're my best friend. That's what developing a passion is like. And so how do you go through struggle with something? How do you get to a level of depth with something? And I think young people need that forcing function to do that, because inherently, most people don't want to do the thing that's hard. Inherently, you don't want to do the thing that's ambiguous because you don't even know if the outcome is going to be a positive one or not. And so how can we put forcing functions in place for people who are excited enough about a topic to go deeper into it? It's not about, I'm not passionate about this, so I don't want to go deeper into it. No. It's, are you excited enough about it? Are you interested enough about it to go deeper into it? So for example, Nina's journey, she might have learned about AI, blockchain, nanotech, gene editing, and then we had our session on longevity. And that's the thing where she was like, I'm interested enough to go deep. Okay, so how do you do that? Then we have a process, so that's the explore process. Then we have a process called focus. And this is where you get to your level of depth. And it is heavily focused on project-based learning. You must do, and you must struggle, and you must accomplish something. So I'll give you an example. Say someone really got excited about AI, mm-hmm. and they wanted to go deeper into computer vision. The first project is called a replicate. And it's very simple. You're replicating something that already exists, and it doesn't have to be some game-changing thing, you could be following a tutorial. So say you're following a tutorial on how to build a lane detection algorithm for self-driving cars, which, by the way, there are many tutorials online to do. It's actually not super difficult. You might not even know how to code. You just learn the syntax and you learn by doing. Great, you accomplish this thing and you feel good. Now you can add something to your portfolio. I built this thing that sounds kind of fancy, right? Now the second replicate is way, way harder. So we're kind of going from 0 to 1 real quick, right? Way, way harder, but it's possible because it's still a replicate, right? You're still replicating something that already exists. So now in this example, it might be developing a computer vision algorithm to detect skin cancer, 7% more accurately than dermatologists. It's difficult on a bunch of different dimensions, especially if you want to build the algorithm from scratch. You got to train it, you got to do all these things. But again, it's possible because it's a replicate. So now you accomplish that. And now in a short period of time, in like 6 months, you feel like a superpowered human being. Now you do your create, which is how can I apply what I've learned to something completely different? It's no longer replicating. It's doing something else. And the reason why we do that is because these young people need to learn how to deal with ambiguity. It's so easy for me to tell you this is the thing you should build. Smart young people will figure out how to build. But you making the decision and falling on your sword how you're going to spend your time over the next couple months to accomplish this thing that you might not even think that you can accomplish. And so in this example, one of our students built a computer vision algorithm to detect rare diseases. And what he did was he just subtracted healthy images from common diseases and you get rare diseases. And now doctors can use this as a tool whenever they're looking at an MRI or CAT scan to identify potential conditions or diseases that they missed. And this kid was 16 years old. He did this in 7 months and was getting hailed as like this genius kid. And they were asking him on these podcasts. And when he was speaking, they're like, how'd you do this? He's like, I just followed the process. Like, I don't know what to tell you, right? And so that really is how you do it, is you get this exposure and you go pretty deep. And then at that point, say you do that twice. Say you do a focus on longevity and AI. Now, all of a sudden, you can think about the intersections in these fields, because it's unrealistic to believe that a 16-year-old can become an expert in AI or an expert in longevity. There's so many other people that have been working for so long in this space. But what is more palatable and digestible is that a young person can become an expert at the intersection of two emerging technologies, because way fewer people, who are the experts in AI and the experts in longevity, ever crossed domains. And now there's a much smaller subset of people in the world who can even think about the possibilities of these intersections. And that's the final stage of the process, which is called innovate. So you go through that process and this is what the outcome looks like.
And working with that, talk a little bit about the partners now, if you would, because Nestle, Microsoft, Walmart, they're lining up for for these folks.
Yeah. So initially, most people are excited because it's cute, right? They're like, oh, look at these kids, plus emerging technologies. Like, we want to support. Maybe it's a part of their D&I initiatives, right? Of like, let's work with a younger demographic, until they realize, and until you talk to a kid. So it's funny, I'll tell you a story about the late Tony Hsieh. So Tony Hsieh was the founder and CEO of Zappos.
Yeah.
He recently passed away about a month ago in a tragic fire, and I was actually with him all summer. So it actually does hit a little closer to home. But I met him 2.5 years ago. And the way we met is our students were at CES, which is the Consumer Electronics Show. It's one of the largest consumer electronic shows in the world. And the reason why they were there is because there was an award called the Young Innovators to Watch Award, which historically was only open to students in the US. And this is before TCAS even had a global program. So we were still in Canada. We only had Toronto. And this was the first time that they decided to open it up to Canada, right? They choose 3 high school students from all of the US who are working on game-changing technologies, not cute stuff, not just projects, but game-changing technologies. In the first year they opened it up to Canada, all 3 winners ended up being from TCAS Toronto. Just think about that, which was insane. And so they were like, okay, well, this is a historically US competition. Let's open it up to more people. So they opened it up to 3 more, and 4 of the 6 ended up being from TCAS Toronto. So anyway, they flew them down, win this award at CES, but all the after parties were for people who were 21 plus, and these people were 15, 16 years old. And so we had to find a place where the kids can go and have a good experience and network. And Tony, who's the founder and CEO of Zappos, he lived in an Airstream at the time. It's kind of like a trailer park, and he had he's very eccentric. He has a llama and a sloth and, a puppy running around with like spiked purple hair. And so it's really cool. And these kids got to go in and meet a bunch of interesting people. And they meet Tony, and we trained them on how to go up to people and strike conversation. So they're talking with Tony for about an hour on everything from AI, quantum computing, proteomics, gene editing. And Tony is just interested in all this stuff. Like he reads a lot. And so he was able to have a conversation with him. And he was like, first of all, how the heck did you get in here? Because like, you know, it's not meant for 16-year-olds. Like, why are there 16-year-olds running around at my party? And second of all, how do you know about all this stuff? Right. And that's the thing that got him really excited. And so they pointed to me, and Tony and I ended up having a conversation, and it's a fun story that I can expand on later, but he convinced me to miss my flight and just go to dinner with him and stay with him and all this stuff. And he asked me, he's like, I want TCAS in Vegas this year. I don't want to wait. What do I have to do? And we pretty much problem solve a way to make it happen because he met the kids. And then when we think about Microsoft was really interested because we did a challenge with them. They were scaling their AI school, and they wanted to figure out a way for their online school to just reach a lot of people. And our kids were looking at their product and they're like, Nadeem, should we focus on scale? Because the product isn't actually that good. And I was like, that's fine. Give them recommendations on product. And so assume the product is amazing. How do you scale? But also give them recommendations on the product, which they weren't expecting, and blew them out of the water. And they were like, this is better than MBA capstone project that we see, because we trained them on how to do this. And through that, the SVP of Microsoft ended up meeting some of our kids, inviting them to speak at conferences all over the world. So Isabella was just at Microsoft's internal conference in Vegas, spoke in the T-Mobile arena in front of 30,000 people, standing ovation, so impressed. Satya Nadella asked to meet with her, and they were talking about for like 30 minutes to 45 minutes on all of these different emerging technologies, right? And so when you meet the kids, that's when you get to see what they're capable of. And then that's when companies get really excited about getting involved on a couple of different ways. I mean, there's obviously mentorship, there's providing financial aid for more students to access the program. And by the way, until this point, we have a virtually unlimited financial aid policy. So like any kid should be able to join if they truly can't afford it. But then also we work with them on challenges, real life business, top business priorities that these companies face. And again, they give it to our kids because they think it's cute. And then they end up coming back with recommendations that are like, wow. So I'll give you an example. Joe Gebbia, who's one of the founders of Airbnb.
Sure.
2.5 years ago, this is during the Trump travel ban, Syrian refugee crisis, the tsunami in Japan. Joe Gebbia felt like it was a personal responsibility for him to provide short-term housing for people who were displaced. And so they invested around 10 million bucks, opened up 10,000 of their homes for free for short-term housing over a couple of weeks, but only 700 displaced people signed up. So he's like, we clearly dropped the ball on this. And at the time we knew the head of Airbnb in North America is Aaron Zifkin, who was like, hey, why don't your kids take a stab at solving this problem? It's like, okay. They did such a good job. So I'll give you an example. One of our students realized that although 70% of Syrians at the refugee camps had smartphones, they only had 2G access, not 3G access. So they couldn't even use the Airbnb app. And that was one of the main reasons why people couldn't access the service, because you had to access the service through the app. And so what he did, Simon, is he built a Twilio integration to turn the smartphone app into a dumb phone app. And it took him like 2 days. And that was like a side part of his recommendation. And he sends it over to Airbnb. He's like, hey, you can use this if you want. Like there's no IP or whatever, just use it. Oh, and here's my real recommendation. And they're like, what the heck? No one on our team came up with this stuff. Ended up flying them down to Silicon Valley, getting a tour of Airbnb, meeting with Joe. And Joe brings in his team, pretty much scolding his team in front of our kids, being like, how the heck did these 15, 16-year-olds come up with this stuff? And you weren't able to figure this out, right? And so we've done challenges with Illumina, which is a gene sequencing company. We've done it with Lego. We've done it with Walmart, a bunch of Sidewalk Labs. And the goal of Sidewalk Labs, which is Google's or Alphabet's spin-off company to build smart cities, their goal was how do you build housing 40% or offer housing 40% below market? So dramatically reduce or improve the affordability of housing. And again, they were blown out of the water. So these are the ways that we typically engage with these organizations. But the key is for them to meet the kids to actually see the level that they're at.
And let's talk about some of the Moonshot companies, because we talked about Nina and Biotine. A small side story here. When I had her on past platform last year, she was in the mix of, other big names in the longevity. I had George Church, Dennis Langer, and Tony Atala, and Nina Kara was in the mix. And people loved the episode. But I got feedback that wasn't great, to the extent of, why are you having this 13-year-old girl on with George Church and Dennis Langer and Tony Atala? And I said to myself, that type of response shows where you've gone wrong, because I come out of the drug industry. It's an industry of failure, right? 1 in 10,000 make it, and everyone's really pissed off at someone else that's trying when they haven't. And I think that encompassed right there that you're doing something right. When you piss off people that have been around 30 years not doing anything. Talk about some of the Moonshot experiences, if you would, and how they're, what else is going on. Obviously, we have the Biotine. Tell us about some of the other ones and some of the other, you're raising money, you're creating prototypes. Talk through some of the ones you're excited about.
Yeah. So first of all, haters gonna hate, right?
Yep.
That's like
I can care less.
Yeah, that's the physics of the world. And so, yeah, I mean, if a 13-year-old is working on something that's really interesting and she's getting validation from some of the leaders in the space,
yep.
But you just don't want it to believe it to be true. And by the way, maybe she fails. Maybe it's dumb. Like maybe focusing on senescent cells isn't the right approach, and we're actually starting to see that that's probably not the leading way. We should focus on longevity, though it does play a big part in it.
Sure.
There are other root causes. That's fine. We've improved the probability that someone now is working on this problem. The person who cures cancer isn't going to turn 30, start working on cancer and cure by 35. Right. The story is going to be, ever since I was 13 years old, I was obsessed with curing cancer, and that's their journey. I'll give you another example of this Moonshot. So Ben, he joins our program at 16, very interested in physics and all this stuff, but doesn't really know anything about coding, doesn't know anything about medical imaging. So he goes through TCAS, learns about AI, and we have a medical imaging session. And something clicks with him, because we talk about at the medical imaging session that MRIs, the technology behind MRIs hasn't really changed in the last 20 to 30 years. But if you look at the rate of change of most other technologies, it's skyrocketed, right? Mm-hmm. And so he's like, why is that? And then he started thinking about problems, why this needed to be changed. And if you look at an MRI image, it's a very shallow image. So if you take an MRI of the brain as an example, it's a very shallow image.
Yep.
And what you can't do is physiologically detect mental health issues, because we don't have a way to image neurons on that level, yep. Right? Very well. And so he was like, well, what if there was a way to do that? Now this is the problem that we can solve, instead of guessing, instead of people being diagnosed with depression or Alzheimer's or whatever the case it is, just by going through to a therapist. But how can we physiologically diagnose these things? And so he was learning about MRIs, and he was like, the technology behind MRIs is we resonate protons in a water molecule, and that's where we kind of get different gradients of the image. And he was thinking, well, what if we can resonate something smaller? A very naive thing, right? So how can we resonate electrons? Maybe that can get us a more granular image. And we can do this. This is something called fMRI, right? And so his life mission between 16 and 17 was to figure out how to disrupt MRIs. And he was learning like PhD level calculus. And I have this picture from way back when of him on a whiteboard doing all these crazy fancy, it was like an Einstein type picture of him just in front of this thing doing the math. And it was very hard for him, but he had to do it, because if someone went under his machine, he needed to make sure they didn't blow up, right? And so again, it's not an easy thing. It's not like he was some genius. Like he was like grappling his brain about how to do this. And then he realized that everybody's thinking about how to make MRI technology bigger and better and more powerful. But there's such awesome technology that we can use to miniaturize this and apply it to other applications, such as non-invasive blood metabolite measuring. And so measuring things like blood glucose levels and cholesterol levels without even penetrating the skin in real time, right? And you can do other things like ketones and whatever the case is, because you're essentially doing what MRIs are doing. You're measuring the signal that the hydrogen in the water molecules or in any of the molecules are spinning at, and then using AI to concentrate that signal. And now you can detect how much blood glucose or cholesterol or some of these other metabolites that you had. And most people were like, oh, this is going to be Theranos 2.0. There's no way you can do this. People have been working on non-invasive blood metabolite monitoring technology for so long. This kid and now this is true, now this is fact, you can't dispute it, he's the first group in the world to quantitatively detect non-invasively blood glucose levels without penetrating the skin. And now he's building a ring to be able to do that within the FDA. Oh, and it's within the FDA band of 15% margin of error. And he just recently raised around $7 million from, I think it was Accomplice VC, but then also people like Sam Altman, Naval, James Cameron, the director, because apparently he's doing tech investments now or something. But that's an example, right? Another example is if you think about solar cells. Well, we have a theoretical capacity of around 25 to 30% right now in solar cells. And in the labs, especially with heat, you're starting to see between 40 and 45. Now, one of the major problems, one of the major reasons why we can't institute solar technology to harness electricity instead of fossil fuels is certain countries just don't have enough sunlight that are hitting, right? So in places like in certain areas in China and the Middle East, the cost per kilowatt hour for solar is actually less than the cost per kilowatt hour for fossil fuels. Fossil fuels is around 3 cents. In some of those areas, it's around 2.5 cents. So interesting fact, China, I think stopped production of 80% of their coal plants last year because now it's not a altruistic problem of how do we prevent climate change. It's this makes us more money if we do it this way. It's just, it's better and more affordable to harness electricity. But most other countries in the world don't get that much sun. So then the second side of the coin is it's unreasonable to expect that you'll be able to create a solution to get more sun to hit a certain part of a region. So the next part of the equation is how do we improve solar cells, the theoretical capacity of solar cells. And there's this technology that came out called quantum dots, which is how can you use a singular photon to knock off multiple electrons in the photovoltaic cell. Because how a photovoltaic cell works is a photon will hit this sheet of silicon, it'll knock off an electron, it'll create a current, and that's how you make energy. And not all photons knock off the electron. This is like the most rudimentary way of talking about this thing, right? And so, but it's like, well, what if one photon can knock off multiple instead of one photon sometimes knocking off one? Now all of a sudden your theoretical capacity goes to 80 or 90%. So we have one student working on that, which again, there's a much higher probability of failure. But as a civilization, we are improving the probability that the problem can be solved because now you have someone working on it. And this is just a part of their journey. It's not about, oh, they didn't accomplish something at 16 or 17 years old, which Ben and I think Nina will, and some of these other people. So, and there's a bunch of other projects that I can talk about, but that's not the point, right? It's these people are on this journey such that when they're 22, 23, imagine where they're going to be then and the problems that they're going to solve. And here's what I do know, 100%. Say Ben's company fails, which it will not fail. Like he already has a patent now that would be useful to Apple or any of these other companies. But say his company fails. There is no way he would ever work on something like a TikTok 2.0, right? Like in his mind, he's like, I gotta work on something that is meaningful, that positively impacts the world. Because the thing that's driving him right now is he had the possibility to go down the commercialization route of just mass marketing it to direct to consumer. But he really wanted to make sure that this could be a medical device. And this is something that might change because he was so passionate about making sure that people who were diabetics could use this as a replacement versus their freestyle Libra or like the traditional finger prick method, right? And so, yeah, I mean, these are a couple of different things that students are working on and the types of projects that they're working on and where their ambition is leading them. And super excited to see where, and now keep in mind where we've scaled 3x in the last, or 3x in the last year and a half or 2 years. With COVID, we actually grew because now we have this fully virtual program. So we have more people who are starting to work on these things. So what I'm really excited about is in 2 to 3 years to see how many of these students kind of pop up that are working on these game-changing problems.
Yeah, I wanted to go right into that because I see obviously with the last year the virtual program is amazing. Physical Toronto, Ottawa, Vancouver, New York, LA, Boston. Just what post COVID? What's the big plan for continuing to expand the physical model?
Yeah, so there are a couple of different things there. One, one thing we learned is that there is no substitute for the in-person experience.
Sure.
Like it's almost like, imagine climbing Mount Fuji with someone on the other side who's on FaceTime with you versus someone who's right next. It's just not the same experience. And so, but that being said, not everyone has the luxury to be able to do that. Like, we have students in this program from small towns in Russia and Italy and in Texas, where they're all friends and connecting with each other, whereas in their town, there was no possibility of something like TCAS ever existing. So the virtual program definitely serves a purpose there. But again, I don't think there is a substitute for the in-person program. And then the next step is, how do we double down on our virtual program such that we can make it a lot more affordable to anyone? Because right now it's around $500 a month, around $450 a month after financial aid, if you take the weighted average cost. But that's still a lot for many people, especially if you're thinking about a 14 or 15-year-old, and parents are just thinking about, well, if I were going to spend, $4,500 on something, I'd rather have it be SAT prep or like math tutoring, because the ROI is them getting into university. And yeah, it's hard to map what we're doing at TCAS with what their ROI is from a parent perspective. So how can we build something? Here's the problem statement. And COVID was actually a really good forcing function for us to test this virtual program and validate a lot of things. The problem statement is, how can we achieve 80% of the results at a fifth to a tenth of the cost that can service over 100,000 people? That's the problem statement. And Naveed and I have a bunch of different hypotheses of how we can do that. So just stay tuned for that when that comes out. But I think we're really excited about what we will be able to build based on our 4.5 years of running TCAS, testing out this virtual program, understanding how people work and think. We didn't start this as an education company, right? We started this as we wanted to build an institution that trains people to solve important problems in the world. What we realized is, even if you're the smartest person in the world, that's not holistic education. Mindset, skills, knowledge, and networks. You need those 4 things to be able to maximize the probability of you doing anything meaningful in the world. And so we had to think about this new education model. And I talked about the TCAS process, right? That is a new learning model that you, of course, don't see in schools. You don't really see it in universities. Like, you really only get to build something, in your 3rd or 4th year engineering capstone project. Like, why? Right? Even in software engineering, you're learning a bunch of this theory, and like, you maybe just build a button and that's what you get graded on. It's like, build a whole website, build something else, right? Build a video game, which some schools definitely do. But why do you got to wait till you're 20, 21 to be able to do that? Like, build that at 14 or 15 years old. So building this different model, but now figuring out how to remove a lot of the operational complexity. And I think the way you do this is through technology. It's going to be a complicated way to do it, but we need to make it feel simple. Kind of like a video game, right? If you look at a video game, it's so complex to make. Or think about like League of Legends and matching algorithms and all that stuff. But when you open up the League of Legends client, it's so intuitive. It feels so simple from a user experience, but to make all of that stuff, to make the rankings, to make the champions, how they all interact and balance and do all that, is very, very complex. So there's a lot of work ahead, but I definitely do think it's possible.
Very exciting times, and amazing what you've put together. And just wishing you the best with this, and to continue to accelerate these young minds in this fashion. For everybody that's going to be watching this episode on the YouTube channel or listening on the podcast network, you've been listening to Nadeem Nathoo, co-founder of the Knowledge Society, focused on unlocking the full potential of all our young folks so they could solve many of these world's biggest problems that have been seemed unsurmountable, but it looks like going to be solved very shortly with these amazing minds and the program behind them. Nadeem, it's been really wonderful talking to you and listening to this story. I want to thank you for taking the time out of your schedule to educate us and everything you're doing and tell the story. And as we say, thank you for creating a better tomorrow. And it seems like you've definitely put these amazing minds on that path for all of us.
Yeah. Thanks for having me. The one thing that I would say is, if
Please.
people were interested and curious about these emerging technologies, because I can imagine these listeners being like, oh, this is really cool. How can I get exposed to a lot of this stuff, right? There are some awesome YouTube channels. Like if you look at Cold Fusion as an example, that's an awesome YouTube channel. There's something called 2 Minute Papers, which is this amazing host. He pretty much breaks down the leading advancements in AI in 2 minutes in a very fun way. So there are ways to get this exposure, and I would highly encourage you, no matter how old you are, to just take a little bit of an effort to look into this stuff, because I think it'll help you get a better understanding of the world and figure out where it is that you're excited about to play a part in this ecosystem and development. So none of this stuff is a secret. It's not hidden in a way. It's not just in the minds of, PhDs or professors at MIT. It's out there, and definitely take some time to look into some of these resources.
Absolutely. We'll put links, of course, to TKS, but also to some other sources as well.
Cool.
Really great
Awesome
stuff. Great
Thanks,
seeing
Ira.
you.